Hey y'all, in this video I'm going to go over how to find the molecular formula. These are the notes that I did together in class for the students who were here. So I'm just going to run through them and explain each step along the way. Previously we did empirical formula, which was the smallest whole number ratio for that molecule. However, molecular formula is going to be the actual whole number ratio, which is typically something like a multiple of 2 or 3 in comparison to the empirical formula. The example that I gave for this one is C4H6O and a molar mass of 140.0 grams per mole. This is the molecular formula mass. That's going to come in handy in just a second. For step 1, it's find the empirical formula. For this example, I gave you the empirical formula, so we didn't have to do those steps. But for the ones on the test and the study guide, you do have to find the empirical formula first. So you may want to go check out the other video titled Empirical Formula Notes to see how to do that if you need a refresher. Step 2 is to calculate the molar mass of your empirical formula. So for this one, I had C4H6O. So I wrote those 3 elements, carbon, hydrogen, oxygen, and wrote how many I have of each. C was 4, hydrogen was 6, and oxygen is just 1. It's understood. These numbers are the numbers that you get from the periodic table. So for instance, carbon is what we had here, and that is 12.011. So that's where this number comes from. Same thing with hydrogen and oxygen. Multiply those out across and add them all together. This is the molar mass. Okay, that's the grams per mole for C4H6O. The next thing that you do is step 3, which is calculate the multiplier. Remember I said it's going to be some multiple of your empirical formula. This is how you calculate the multiplier. You take your given molar mass, okay, whatever is given to you in the problem. In this case, it was 140.0, divided by your empirical molar mass. Okay, this is your molecular molar mass on top divided by your empirical molar mass on the bottom. The empirical molar mass is what you just calculated, whatever that number is. Okay, if you ever get confused about which number goes where, remember that the bigger number always goes on top. So for this one, I have 140.0 divided by 70.091. That gives me 2. Which means that my multiplier is 2. So I'm going to take, for step 4, this multiplier and my empirical formula and multiply those together. Okay, here's what I mean by that. I'm multiplying the empirical subscripts for step 4. This is the last step to get the molecular formula. This is the molecular formula. My multiplier, that's from step 3, was 2. Times the empirical formula, C4H6O. That was given to me in the original problem. Sometimes you will have to calculate that. To get this, you're just multiplying the multiplier times the subscripts for each of them. So C was 2 times 4, which is 8. H was 2 times 6, which is 12. And O, because there's nothing there, it's understood that there's a 1. So 2 times 1 is 2. That's how you find the molecular formula.